Hello students, in this class I want to explain about region based segmentation. In the previous video I explained about segmentation using edges and different thresholding methods. If suppose edges and thresholds sometimes do not give good results for segmentation, then we can go for this region based segmentation. In the first classes of this image segmentation concept, I told that the segmentation is based on two things, discontinuity and similarity. Discontinuity based segmentation involves edges and thresholds, and similarity based segmentation is this region based segmentation. Region based segmentation is based on the connectivity of similar pixels in a region. What is this region? Region is having uniform intensity or uniform texture or uniform color or uniform gray level, like that. So, and another point is region must be connected. So region based segmentation is based on the connectivity of similar pixels in a region. The similar pixels means having same color, having same texture, having same intensity, like that. Okay, and the region must be uniform. To apply this region based segmentation, region must be uniform, and connectivity of the pixels within the region is very important. Means there must be either 4 connectivity or 8 connectivity or M connectivity. Then only we can define or we can go for a region based segmentation for that region. There are two main approaches to region based segmentation: region growing and region splitting. First, we'll see the basic formulation for this region based segmentation. See, let R represents the entire image region. Okay. Yes. Then segmentation is a process that partitions R into subregions. Yes, R is a full region. Segmentation divides this R into different regions. Those regions are represented like R1, R2, etc., Rn, such that, what is the first point? The first point of the condition is union I is from 1 to n, Ri is equal to R. Means if you mix or if you merge all the regions, you must get your original image. Okay, means the segmentation must be complete. What is the segmentation? Dividing the image into some similar parts, some similar regions. Again, if you merge all those regions, you must get the original image. Then only the segmentation is called complete segmentation. Another point, Ri is a connected region. Means there must be some connectivity of the pixels in that region. Means the pixels in that region must be connected. There must be connectivity. Okay. And then Ri intersection Rj. Take two regions, Ri and Rj. These two regions, if you go for intersection between these two regions, means the commonality between these two regions, it results the null set. Phi means null. Means Ri and Rj are disjoint regions, different regions. Ri is having some similar color or texture or intensity. Rg is having some similar color, texture or intensity. Okay. So, the two regions must be disjoint. And this one, P of Ri is equal to true. For I is from 1 to etc. n. What is P of Ri? P of Ri is a logical predicate defined over the points in set Rk. Logical predicate means it's a condition. Okay, suppose if, take Ri, the region Ri. Suppose if your condition is the region, the pixels in the region must be red color, having red color. Okay, you can call that as a region if the pixels in that region are having red color. Means all those pixels are satisfying this predicate, the condition. Okay, then you can call the group of pixels as region. And another point, P of Ri union Rj is equal to false. Means if you apply the same predicate on two disjoint regions, if it will give false, means you won't get any value because Ri and Rj are disjoint regions. Predicate is true or the condition is true only for single region. Okay, because the regions are different, the same predicate will not be satisfied by the other region. Okay. So this is the basic formulation for region based segmentation. Now coming to the region growing. Region growing is a procedure that groups pixels or subregions into larger regions based on predefined criteria. Region growing means is that groups pixels or subregions into large regions Getting a larger region from small regions is called region growing. Okay. What is the basic approach? The basic approach is to start with a set of seed points and from these grow by appending to each seed those neighboring pixels that have properties similar to the seed. This region growing starts with seed points. Seed points. Okay. Then, yes, the region is getting improved or the region is getting larger by appending to each seed those neighboring pixels that have properties similar to the seed. I will explain. Suppose take the seed here. This as a seed means let it be a single pixel to understand. Suppose if this is the entire image, if this is the image, okay, it consists of, let us assume that it consists of so many objects or regions. Take the seed point. Okay, now there are other pixels like this which are in other different objects. Okay, this is the seed one. Is consider this pixel to check the similarity between these two pixels. Suppose if the seed point gray color and you have the chosen point gray color is same, then connect these two. Connect these two. Okay, means you improve the region. Then go for this. Again, you calculate the similarity between these two. Yes, if these two pixels, the seed point pixel and these pixel are having same gray level, then also add this. Then it becomes the region. Then go for this. Then again find the similarity between this seed and this pixel. If same happens, then add this to this region. Okay, then go for this. If there is no similarity between this seed point and this pixel, leave that pixel. Again go for this. If it satisfies, then add this. If it satisfies, then add this. So it is becoming a big region. We started with only a small seed point. Because of the similarity between the seed point and the pixels, yes, the region is becoming larger. Means there is region growing. This is a region growing concept. So you can call this region as the segmented region. You can segment this region. Okay. So the region growing works in the following way. I'll see the steps. Step 1. Choose seeds. Okay. As I explained, choose seeds. Select one or more seed pixels. Okay. These seeds act like starting points for each region. Okay. Means seed point is starting pixel. How to choose this starting pixel? When you observe, I'll show you one example. See this. This is the image. Okay. What you have to do is you have to segment this part, defective parts. These are called defective parts. Okay. These white portions are called these white portions are called defective parts. Okay. The aim is to segment only those regions. Then yes, by observing only we can say the seed must be in these regions, in these white regions. Okay. So accordingly you choose one seed like this. Yes, these are the seed points. See here. Because we know the image. Okay, otherwise, how to choose the seed point? You plot the histogram, and in the plot of histogram, you'll get some highest peak points. You choose that highest intensity as a seed point. Okay, then step 2. Define similarity criteria. Yes, as I explained here, define similarity criteria. A pixel can be added to a region if it is similar enough to the region. Similarity can be defined using gray level, color, texture, or distance from regions, mean, gradient, spatial connectivity, like that. Okay, if the seed point and the considered pixels are having same gray level, then add that pixel to the seed. Grow your region. Or if the color is same, grow your region. Texture is same, add that pixel to the seed. Or distance from regions mean is less, then add that. If the gradient value is less, gradient value is high means there exists edge, gradient less means there exists similarity. Okay, then add that pixel. If the two seed point and pixels are having some connectivity, then also add that pixel. Okay, so that is step 2. Step 3. Grow the region. For each seed, check its neighboring pixels. If a neighbor meets the criteria, means the step 2 similarity criteria, add it to the region, continue checking neighbors of the newly added pixels. Okay, so in that way you can grow the region. Stopping rule. What is the stopping rule? The region stops growing when no more neighbors satisfies the criteria. Okay, so suppose see here I explained. Suppose Suppose this is the pixel. For this pixel again, if there is another pixel, you have to go for the similarity between these two. Then it becomes a seed. Yes, you have to check the similarity between these two. If these two are same, again you grow the region. Okay. Yes. Suppose if there is no similarity, means the region stops growing when no more neighbors satisfies the criteria. You have to check the similarity between the seed point and all the pixels of the image. Okay, the region growing must stop when the similarity criteria is not satisfied further. Okay, then. So region growing uses pixel similarity and pixels connectivity. This combination allows region growing to segment meaningful continuous areas even when simple thresholding fails. I'll explain this with an example. Already I have shown it to you. What is the first one? Image showing defective wells. These are all the defective welding. Okay. Seed points. These are the seed points. Okay. Then results of region growing. Yes, these are the seed points. By finding the similarity criteria between the seed points and the adjacent pixels or neighboring pixels. Yes, this is the result of region growing. Then these are the boundaries of the segmented defective wells. We'll see how it was carried. See, in the well inspection example, means in this previous example, seeds were chosen as all pixels with gray level 255 because the defective wells usually appear with maximum intensity. If you see the image, these defective wells are having the white intensity, means that is the maximum intensity. So that is the reason. Seed points means the pixels which are having 255 intensity. See here, these are the seeds. Okay, only these white portions. And then a pixel was added to a region if its gray value differed from the seed by less than 65. And the second point is it was 8 connected to that region. So there exists similarity of the intensities. Because it is not connected, you must avoid it. Okay, the pixel touched two regions. The regions were merged. Okay, the grown regions accurately matched the defective well areas. Explicit stopping rule was needed because the criteria naturally stopped growth. The rule is not required because the criteria naturally stopped growth. Then this is the histogram of this welded image. This is the histogram of this image. Okay, if you see the histogram is having multiple peaks. Means you can't do this segmentation by using thresholding. Because what is the meaning of thresholding? You have to choose a threshold between the two peaks, between this histograms, between the two peaks of histograms. But if you see, there exists many valleys. And many peaks. This is one peak, this is one peak, and this is one peak. There exist multiple thresholds. So this example shows that the simple thresholding fails with multimodal histograms, but region growing succeeds due to the use of connectivity. So this is about the region growing. Now we'll move to the region splitting and merging. Region splitting is the opposite of region growing. Fine. First, there is a large region, possibly the entire image. Then a predicate measurement is used to determine if the region is uniform. You have to check one condition, whether the total region is having same color, same texture, same intensity, like that. If not, then the method requires that the region be split into two regions. If the total region is not satisfying the predicate, then you have to split the region into two different regions. Then each of these two regions is independently tested by the same predicate again. Okay. So you have to consider the entire image first, then apply a condition on that image. If the total image is having same similarity, means same gray level, same intensity, same color, then no need to split. The total image becomes the region. Then no need to go for any segmentation. But if all the pixels of the region are not satisfying the predicate, you have to split the image into two parts. Again, for each individual region, you have to apply the same predicate. Individual regions are again not satisfying the same criteria. Again, you have to split those two regions. Okay, means how it will happen? Suppose if this is the total image, then if the total image is not satisfying the similarity, split it. Again check the condition for these two regions. If it is this subpart is not satisfying the criteria, then split it. Yes, then again if not satisfying, then split it. Then split it like this. You have to split. Okay, then these regions becomes your segmented regions. Okay, this procedure continues until all resulting regions are uniform. Okay. Okay, so after splitting this, again you check this. Suppose if it is not satisfying, then divide it. Okay, then yes, divide it, then divide it like this. Then go for this part, then divide it. Otherwise, like this. You have to split the entire image. Okay, if there is no similarity. Yes, the main problem with region splitting is determining where to split a region. Okay, one method is to divide a region to use a quad tree structure. See this quad tree, a tree in which nodes have exactly 4 descendants. See this is the entire region. Here the region is divided into first 4 parts and then the 4th part is again divided. If you want, you can divide again R4, 4 again. This is the structure, partitioned image, and this is the corresponding quad tree. Yes, this is the split and merge procedure. Split into 4 disjoint quadrants any region Ri for which P of Ri is false. Okay. Yes, why we are splitting? I already told this, the opposite of region growing. In the region growing, you are growing the region if there exists, if the similarity or if the predicate is satisfied between the seed and pixel. But here, if the predicate is not satisfied, you have to split. Okay, so that is P of Ri is equal to false. Merge any adjacent regions Rj and Rk for which P of Rj union Rk is true. Suppose after splitting like this by using this quadrant. Suppose see this, if R44 is splitted like this again. Like this. Suppose if these two regions are satisfying this predicate, then merge these two. If these two regions are satisfying the predicate, then merge these two. Okay, so in the region splitting and merging concept, you have to split simultaneously, you have to merge. Split the regions which are not satisfying the similarity or the predicate. Merge the regions which the predicate is true. Okay, so stop when no further merging or splitting is possible. Okay, so continuously you have to split. And continuously, simultaneously you have to merge if the same condition is satisfied by the two regions. So what will happen? Imagine, okay, in the final stage, you are going to get different regions. Am I correct? Different regions. Why you are splitting? Because the regions are different. Why you are merging? If the two regions are same. So then what will happen? Image is divided into unique parts. That is called segmentation. So this is a segmentation. See the leaf image, original image. Yes, this is the result of split and merge procedure, and this is the result of thresholding. Okay. So this is about region splitting and merging. Thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.